Let us look at evolute of a curve. Let's say we are given a curve. We take an arbitrary point on that and we draw a tangent at that point to the curve. And at the same point, we draw a perpendicular to the tangent. We have already seen curvature. We have seen the center of the circle of a curvature. So let's find the center of the circle of curvature. Now, this circle is such that when we draw this circle, it will hug the curve. And if I move this point on the curve, what the center of the circle of curvature does is it moves. It moves tracing a curve, another curve. This curve, this orange curve, is called the evolute of a curve. Now, as you might have noticed, that drawing it geometrically, it is pretty straightforward. But how to figure this out in the form of a equation or a function? That is what we will do today. Now let's look at this in general first. Let's say we are given a function y is equal to f of x. And we take a point P on this function. Now, as P moves, xy changes. So when it moves, x changes. So accordingly, y changes. So which means y is a function of x. Accordingly, rho, the radius of curvature, changes along the curve, which implies that the center of the circle of curvature changes. So let it be x1, y1. Now the center of the circle of curvature is given by this. We have already seen this in previous sessions. So x1 is equal to x minus y prime times 1 plus y prime square divided by y double prime. So here remember, y prime is the first derivative and y double prime is the second derivative. And y1 is equal to y plus 1 plus y prime square divided by y double prime. What we have to do is eliminate x and y, these two expressions for x1 and y1, so that we end up with y1 is equal to g of x1. And this is called the evolute of the curve y is equal to f of x. Finally, we substitute x1, y1 because that will remain with x and y to generalize. Okay, so let's begin. So y square is equal to 4ax. Let a equal to 1. To parameterize it, let y is equal to 280. So if we substitute 280 here, we get 280 square is equal to 4ax. Simplifying it, we get 4a square t square is equal to 4ax, which implies x equal to 80 square. So we have got x equal to 80 square and y equal to 280. Now let's differentiate x with respect to t. So we get dx by dt is equal to 280. Now we differentiate y with respect to t. We get 2a as dy by dt. But remember, what we are interested in is dy by dx. So we use these two to evaluate dy by dx. So dy by dx is equal to dy by dt divided by dx by dt. When we convert this into multiplication, we will get dt by dx. Dt gets cancelled, we end up with dy by dx. So here dy by dt is 2a and dx by dt is, so we have 2a by 280, which gives us 1 by t. Okay, now let's differentiate it once more because we also need the second derivative. So d2y by dx square is equal to minus 1 by t square times dt by dx. What is dt by dx? Is the reciprocal of 280. So we have minus 1 by t square times 1 by 280, which gives us minus 1 by 280 cube. So we have the first derivative 1 by t, and we have the second derivative minus 1 by 280 cube. Now let's go back to our expressions for the center of curvature, x value and y value. So we saw x1 is equal to x minus y prime times 1 plus y prime square divided by y double prime. So let's do the substitutions. x1 is equal to x is what? 80 square minus y prime. Y prime is dy by dx, which is 1 by t. 1 plus y prime square, so 1 by t square, divided by the second derivative, which is minus 1 by 280 cube. Simplifying this, we get 80 square minus t square plus 1 by t cube divided by minus 1 by 280 cube, which is equal to 80 square plus t square plus 1 times 2a. x1 is equal to 80 square plus 280 square plus 2a is equal to 380 square plus 2a, which is equal to a times 3t square plus 2. That is x1. Now let's look at y1. Again, we do the necessary substitutions. y1 is equal to y is, where is y, 280 plus 1 plus y prime is 1 by t. So 1 by t square divided by y double prime, which is minus 1 by 280 cube. So simplify. So that finally we get y1 is equal to minus 280 cube. So we have got x1, we have y1. That means we have the coordinates of the center of the circle of curvature, A times 3t square plus 2 comma minus 280 cube. So x1 is this, y1 is this. Let's solve it for t. So we have t square is equal to x1 minus 2a divided by 3a. And here t cube is equal to minus y1 by 2a. Here the problem is that this is t square and this is t cube. So we have to equate it. To do that, we cube this and we square this, so that this becomes 2 to the power of 6 and this becomes 2 to the power of 6. So we get t to the power of 6 is equal to x1 minus 2a by 3a cube, and t to the power of 6 is equal to minus y1 by 2a square. Let's simplify this. We get t to the power of 6 is equal to x1 minus 2a cube by 27a cube. And here it is t to the power of 6 is equal to y1 square by 4a square. So now the left hand sides are equal. That means the right hand sides are also equal. Again, simplifying this, we get 4 times x1 minus 2a cube is equal to 27a times y1 square. Now what we do is we substitute x1 with x just to generalize this, because a general statement should have x and y and not x1, y1. So we just replace it with x and y. So we end up with 4 times x minus 2a cube is equal to 27a times y square. Now we can write this in a slightly different form, which is much more familiar. That is, y is equal to plus or minus square root of 4 times x minus 2a cube divided by 27a. And if we plot this, we get this. And in the beginning of the session, you saw this is what those points were tracing. That was evolute of a curve. Again, let me remind you, there is a link to a PDF book which describes all these in detail. Please feel free to download it, refer to it, and if you think somebody else can also benefit from it, please do share. That's it for now. Bye.